Dear students, we studied about the dielectric substances and polarization of dielectric substances. Scientists observed this thing when dielectric substance is introduced between two plates of the capacitor, its capacitance can be increased considerably. So let's understand this thing. So effect of dielectric on capacitance. Suppose first we think about a parallel plate capacitor with no medium between two plates. It implies that there is vacuum between these two particular plates. Suppose charge of the capacitor is Q and here area of the plates, that is A, the separation between two plates, that is D. Now when there is no medium between these two plates, it implies that when there is vacuum between these two plates, at that time the electric field between these two plates, that is sigma upon epsilon 0. We derived these equations. Then potential difference between these two plates, that is V0, that is E0 into D. And the capacitance of the capacitor, that is epsilon 0 A by D. Okay. Now, if the dielectric substance is introduced between these two plates of the capacitor, then we know this thing due to polarization of the dielectric in the presence of external field. Here which field is present? So electric field of this capacitor means electric field between two plates of the capacitor, that is present. And now in that particular electric field, this dielectric substance is introduced. So here what happens? Resultantly, at the surface of the dielectric substance which is close to the positive plate of the capacitor, the negative charge will be induced. And here the surface of the dielectric substance which is close to the negative plate, the positive charge that will be induced. So inside the dielectric substance, due to its polarization, here suppose the surface charge densities are plus minus sigma p, and due to that the electric field in the opposite direction of the external field will be developed, and that is EP equal to sigma p upon epsilon 0 as shown in the figure. Clear to all of you? Now see, here the electric field resultant one, that is E0 minus EP. E0 that is sigma upon epsilon 0, EP that is sigma p upon epsilon 0. So here we can say the resultant electric field between these two plates of the capacitor, that is E equal to sigma minus sigma p upon epsilon 0. Now easily you can understand this thing. This sigma p directly proportional to sigma. So we can say this sigma minus sigma p, that also proportional to sigma. Here we can say the potential difference V, that is E into D. So that is sigma minus sigma p upon epsilon 0 into D. Now if sigma p proportional to sigma, then we can say sigma minus sigma p also proportional to sigma. So sigma minus sigma p proportional to sigma, so that we can write sigma minus sigma p, that is sigma by k, where k, that is the proportionality constant here, that is the characteristic of dielectric substance, and its value, that is always greater than 1. So here sigma minus sigma p, if we replace by sigma upon k here, then we can write E, that is equal to sigma upon k epsilon 0, and you can write V, that is equal to sigma upon epsilon 0 k into d. Now see, when V, that is sigma d upon epsilon 0 k, here we replace sigma, that is the surface charge density, that is q by A. So we can write qd upon A epsilon 0 k. Now the capacitance of the capacitor, that is the ratio of charge to potential difference. Here on the capacitor, charge is q. When dielectric substance is introduced between two plates of the capacitor, there will be no change in the charge which is deposited on the plates of the capacitor. So we can write here, now new capacitance of the capacitor when dielectric substance is introduced, that is C equal to Q by V. So we can write C, that is Q by V, that is epsilon 0 K A by D. But epsilon 0 A by D, that is original capacitance of the capacitor when the dielectric substance was not introduced. So we can write C, that is equal to Kc0. Here, this K, that is known as the dielectric constant of that particular dielectric medium or dielectric substance. So we can say this thing, when the dielectric substance having dielectric constant K is introduced between two plates of the capacitor, then capacitance of the capacitor, that is increased by K times. Now epsilon, that is equal to epsilon 0 K. So here we can write this epsilon 0 K, that is epsilon which is known as the permittivity of that particular medium. Permittivity of that particular medium. So here we can write K, that is epsilon upon epsilon 0 also, and epsilon upon epsilon 0, that is known as the dielectric constant of the substance. It is also known as relative permittivity of that particular dielectric substance. Clear to all of you?